This is the Unit 4 review for Math 2 honors. Number 1, we're trying to solve for x. There's something missing in this picture in order to do this, and that is the segment CD is equal to segment DA. So D is the midpoint of AC. Also, EB is the segment EB is the same length as the segment AE, or in other words, E is the midpoint of AB. And what we've learned is that when you have a segment connecting midpoints, we call the midsegment, and that length of the midsegment is half the length of the base. Or we can put it as the base length is 2 times the length of the segment. And so that's what I'm going to write. The base length, x plus 5, is equal to 2 times the shorter length, which is x minus 8. And then from here we can solve by distributing 2 and I'll add 16 to both sides. Subtract x from both sides, and you get x is 21. Number 2, if AB is 2x minus 5 and gx is 3x plus 5, find AB. So again here we're going to assume that AB is a mid-segment. So there's some missing pieces here. Length GA is the same as length AH, so A is a midpoint of GH. Also, the length of JB is the same as the length of HB, so that B is a mid-segment. Sorry, B is a midpoint, making AB a mid-segment of this triangle. And then a fact that we know is that the length of a mid-segment is half the length of the base it's parallel to, which would be GJ. So GJ is equal to 2 times the length of the midsegment AB. And so plugging in these in, we hit 3x plus 5 is equal to 2 times 2x minus 5. Distribute the 2, and we get 3x plus 5 equals 4x minus 10. I'll add 10 to both sides of the equation and subtract 3x, and we get x is 15. But we were not asking for x, we were asking for the length of AB. So AB is 2 times x minus 5, and x is 15. So 2 times 15 minus 5, that's 30 minus 5, which is 25 units, or whatever measurement we're working with here. Number 3, still referring to the picture in number 2, if HJ is 5x plus 1 and AC is 2x plus 5, find HB. Okay, so in this picture, still, we're going to assume that AC is a midsegment in this triangle, so that would mean A is a midpoint of GH, and C is a midpoint of GJ. And now we have that relationship that the base, HJ, is equal to 2 times the length of the midsegment AC. So 5x plus 1 is equal to 2 times 2x plus 5. And subtracting 1 from both sides, we get 5x is 4x plus 9. Subtracting 4x, we get x equals 9. Now we want to find HB. Well, B is the midpoint of HJ. So if we know, we could do this two ways. If we know the length of HJ, we can cut it in half and find the length of HB. Or we can say that the length of the midsegment, AC, is the same as the length of HB. Either way, I'm going to go after HJ first. So HJ is 5 times x plus 1, so it's 45 plus 1 is 46. And so then HB, just from the picture, is half of that, which is 23 units. Number 4, if RS is a midsegment of the triangle LTN, okay, so if it's midsegment, then R is a midpoint of LT, and S is a midpoint of LN. If LR is 8, LS is 10, TN is 12, find well, actually we're going to find all the following. So we want to find LN. Well, if LS is 10, then SN is 10, and so LN is 20. We want to find RT. RT is the same length as LR, so it's 8. SN. SN is same length as LS, which is 10. And LT, that's 16. And we got it. Can the following side lengths create a triangle? Yes or no? The quick and easy way is when you're given 3 numbers or 3 possible side lengths, take the 2 smaller side lengths, add them up, and make sure they're larger than the largest side length. Okay. So here we're going to use the triangle inequality, which states, again, like we said, that the 2 smaller sides have to be bigger than the largest sides. So on the first one, 7, 10, and 5, you take 7 plus 5. Those are those 2 smaller numbers. And you ask if that's bigger than 10. Yes, that's true. And so we say yes. Can the following side lengths create a triangle? Yes, they can. Same idea here. On the next one, you got 12 plus 13. Is that bigger than 25? No. So we can't create a triangle with those 3 side lengths. Next one, 1 plus 4. Is that bigger than 4? Yes, it is. So yes, we can create a triangle. 2 plus 4. Is that bigger than 7? No. So we can't create a triangle. And 19 plus 5. Is that bigger than 22? Yes, it is. So we can create a triangle. So that's using the triangle inequality. Number 6, we're going to list the angles and sides in orders for least to greatest. Okay, so for sides, not too bad here. So least to greatest, the smallest side is NM. Actually, let's do this. Okay, so least to greatest And so side MN is the smallest side length at 10. And so the smallest angle is the angle opposite that side, which would be angle O. The next smallest side would be NO, which is 27. The angle opposite that side would be angle M. And then the largest side is MO, which is 29. And the angle opposite that is angle N. So we have the side lengths from least to greatest, and we also have the angles from least to greatest. Number 7, the lengths of two sides of a triangle are 11 and 25. What are all of the possible side lengths for the third side? So on this one, we have two cases to consider. The first case, well, let's let our third side be x. So our three sides are 11, 25, and x. Well, let's first assume that x is the largest side. If x is the largest of the three, then 11 plus 25 needs to be bigger than x by the triangle inequality. And so from that, 11 plus 25 is 36. So 36 needs to be larger than x. But what if x is not the largest? Then 25 would be the largest. And then we'd get from the triangle inequality that 11 plus x has to be bigger than 25. Solving for x here, we get x has got to be bigger than 25 minus 11, which is 14. And so put these together, x needs to be bigger than 14, but at the same time smaller than 36. So we can, that right there would be our answer. We can condense that. If you put the smallest number on the left and the largest number on the right, this is a condensed version of that, saying x has got to be between 14 and 36. Number 8 through 11, we're going to use the given triangles and draw a segment showing the following. So an altitude is, so of this first triangle, I'm going to go from point x. An altitude in a sense is the height of this triangle. And so we're going to drop a perpendicular to yz, and it's got to go through that point x. So that's our altitude. Number 9, we're going to do an angle bisector. I'm going to bisect angle x. So for an angle bisector, it cuts angle x in half. So that angle yxz is congruent to angle, not z, we're going to have to put another point here. Let's put m here. Is congruent to angle zxm. And that's all we get from the angle bisector. We do not get that m is a midpoint. We do not get that ym and mz are the same. Back to 8, the only thing we get here is that yz is perpendicular to xm. And obviously we get a right angle because of that perpendicular. Number 10, we want a perpendicular bisector. Okay, so first of all, we find the midpoint of YZ, and we draw a perpendicular. So that's the perpendicular bisector. Notice this one does not go through X, unless it was an isosceles triangle. So in this picture we have that YM is congruent to MZ, because M is the midpoint, and we also have that YZ and MN are perpendicular. And then the median, again you find the midpoint and you connect X to the midpoint. So in this picture YM is congruent to MZ, and that's all we have. Number 12, AE is the median of triangle BAN. So that means E is the midpoint, and so BE is congruent to EN. So it's asking, is each statement true or false? AB is congruent to AN. I don't like this as true or false. I would say true or not enough information, right? So A, it could be true, but we don't have enough information. There's nothing that tells us for sure that A has to be true. I will write false, although have that understanding that it might be true. Okay. Angle B is congruent to angle N. Again, we do not know that. BE is congruent to EN. That we know for sure. That's true. And then angle BAE congruent to angle NAE, false. Number 13. Which segment is the longest? Which segment is the shortest? So we have two triangles that we need to compare. So let's go with the longest segment first, okay? So in triangle ABD, okay, the largest angle is 70 degrees, right? And so the largest side is across from the largest angle, which is AB. So in triangle ABD, AB is the longest side. In the other triangle, in triangle BDC, the largest angle is 77, and so DC is the longest side. Okay, so now the question is, which one's longer? Is AB longer or is DC longer? What we cannot do is we cannot look at which angle was bigger. Sure, 77 degrees, 70 degrees went with the AB, 77 degrees went with the DC, and 77 is bigger than 70. But because those angles are not in the same triangle, we have no say of which side is larger. If 70 and 77 were in the same triangle, then yes, the larger angle is across from the largest side. But we have two separate triangles here, and so we can't make that comparison. And so we kind of get stuck on this one. Which segment is the longest? We don't know. So we cannot determine the longest segment. Not enough information. Okay, now let's go after which segment is the shortest and see if we can actually answer that one. So, in a similar way, in triangle ABD, the smallest angle is 46 degrees, and so the shortest side is across from the smallest angle. So AD is the shortest length. In triangle DBC, the smallest angle is 30 degrees, and so DB is the shortest length. And now DB is not the shortest length in triangle ABD. Thus, AD is shorter than DB, making AD the shortest length. So we were able to determine the shortest length. We were not able to determine the longest. Okay, number 14. What is intersecting in each triangle, and what is the point of intersection called? So if we look at triangle A, what's happening in triangle A is we have perpendiculars that's drawn in. So each segment is perpendicular to its side. And what needs to be in this diagram that is missing, I apologize, is that it's not only perpendicular, but they bisect each side. So this should be in here originally. So these are what we call perpendicular bisectors. And all three perpendicular bisectors cross at a particular point, and we call that point the circumcenter. In B, what we see is that each angle is being cut in half, and so these are angle bisectors. And all three angle bisectors meet at a point, and we call that the incenter. All right, part C. What's going on here is each of these segments are cutting are segment bisectors, and we call them medians. So a median is something goes from a vertex to a midpoint of the opposite side, and so C, we have three medians, and they intersect at a point called the centroid. And the last one, we have segments that go through the vertex of one point and are perpendicular to the other side. Those are altitudes, or the heights of the triangle. And the altitudes intersect at a point called the orthocenter. So be familiar with the names of these segments and the names of their intersecting points. 19. Given that a triangle has side lengths 4 and 7, what are the possible values of a third side length? So if we let x be that third side length, we have two cases to consider using the triangle inequality. First is that x is the largest of the three. If that's the case, then we need 4 plus 7 to be greater than x. 4 plus 7 is 11, so x must be less than 11, or 11 must be greater than x. And then second case is when x is not the largest, which would make 7 the largest. And using the triangle inequality again, we need 4 plus x to be greater than 7. Subtract 4 and you get x needs to be bigger than 3. So we need x bigger than 3. And we need x to be less than 11. So x is anywhere between 3 and 11. Number 15. What's going on here is we have an angle bisector, and we have perpendiculars drawn to the angle bisector, forming two triangles. We can say that these triangles are congruent. We have a shared side here, and angle, side gives congruent triangles, and so the corresponding parts are also congruent. So those 5x and the 6x minus 5 are going to be equal. And we can solve for x using this. I'm going to subtract 5x and add 5. So x is 5. Number 16. We have two angles, and in two different triangles. The triangles have right angles, so these are right triangles. The hypotenuse is shared, and they have a leg matching. And so if you have right triangles with the congruent set of hypotenuse and a set of legs, we can use hypotenuse leg congruence to say that the triangles are congruent. And then because the triangles are congruent, we can say their corresponding parts are congruent. In particular, these two angles are congruent. So 3x plus 5 we can set equal to 4x minus 6. Subtract 3x from both sides. Add 6. We get x is 11. Seven, we need to 17, we need to find a few things. We need to find x, lt, and dt lengths. Studying the picture here, we have a perpendicular and two congruent triangles. Well, are they congruent? Well, yes, they are by side angle side. And so their corresponding parts are congruent. So we could let 10x plus 7 equal 8x plus 24. Subtract 8x, and 2x plus 7 is equal to 24. Subtract 7. You get 17. Divide by 2. 17 over 2. LT and DT, because their corresponding segments are going to be equal to each other. We even set them equal here. So if we find one length, then we found them both. So we found x, and now looking for, let's say, LT is 10 times 17 over 2 plus 7. 10 times 17 is 170. 170 divided by 2 is 85. And 85 plus 7 is 92. So that's LT. That is also going to be the length of DT. You can plug it into the formula, but we don't need to because we have triangle congruence. Use triangle DEF, where J, K, and L are midpoints. If JL is 3x minus 8 and EF is 4x plus 2, what is KF? Okay, so here's what we know. JL is a mid-segment of the triangle, and it's parallel to EF, and so the length of EF is equal to 2 times the length of JL. And EF is 4x plus 2. JL is 3x minus 8. Now we can solve for x. Going to subtract 4x from both sides. Add 16. Divide by 2. And we get x is 9. Now we're looking for KF. KF is half of EF. And we found that EF is 9. So half of 9 is 9 over 2. If you change that to a decimal, you get 4.5. Number 20, we want to compare AD and CD. So AD AD is opposite 36 degrees, and CD is opposite 32 degrees. And a fact that we need to know is if we have two sides that are congruent, in this case we do, we have AB congruent to BC, and we have BD congruent to itself. It's shared between the triangles. Then the angle in between those two congruent sides we can compare. In this case 36 is larger than 32, which indicates that AD is going to be larger than DC. So that is our answer. The only reason we're allowed to compare these angles when they're in two different triangles is if you have this scenario where it's in a sense a side angle side type of thing, but the angles aren't equal. You can make this comparison, but it's got to be in this form. 21, find the value of x. Find TW, find WZ. In this picture, we have two right triangles, and they share a side, and they're congruent by side angle side. And so we can, because the triangles are congruent, we can say that 2x and 3x minus 5 are equal. I'm going to subtract 2x from both sides, add 5, and so we found the value of x. To find TW is equal to 2 times x. X is 5, so we get 2 times 5, which is 10. WZ is congruent to TW, so we already have WZ, also 10. You can plug in 5 to get 3 times 5 minus 5, and you get 10 again. 22, the coordinates of the vertices of a triangle are A at 0, 0, B at 4, 6, and C at 6, 0. So draw in your triangle, ABC. A says find and label the points on the graph for the coordinates of D, which is the midpoint of AC. Okay, so A 0, 0. C is 6, 0. And so we could see where the middle is. Put it there. But you can use the midpoint formula, and it's good to know because sometimes it's not so obvious, where you add the x values together, 0 plus 6, and cut them in half. Add the y values together, 0 plus 0, cut them in half. And so D is going to be 3, 0. Alright, so we labeled the coordinate D, which is the midpoint of AC. Also, we want the midpoint of CB. C is 6, 0. B is 4, 6. So E is going to be the midpoint of those two. You add the x values and divide by 2. Add the y values and divide by 2 to get your midpoint. And so we get 10 over 2, which is 5, 6 over 2, which is 3. So the halfway point between C and B is at 5, 3. Right there. And label that E. B asks us to show mathematically that DE is parallel to AB. Graphically, segments are parallel if they have the same slope. So let's look at the slopes and show they're the same. The slope of AB, we could just count rise over run. So run up 1, 2, 3, 4, 5, 6, right 1, 2, 3, 4, which reduces to 3 over 2. The slope of DE, again I'll count rise over run, up 3 over 2. So since the slopes are equal, they're parallel. So DE is parallel to AB because they have equal slopes. C, mathematically show that the length of DE is half the length of AB. So we're going to use the distance formula. So the distance, or the length DE, take the square root, take the two x values of your coordinates. So D is at 3, 0, and E is 5, 3. So we subtract our x coordinates, so it doesn't matter which order. I'll do 5 minus 3 squared plus, subtract your y coordinates, 3 minus 0 squared, and then simplify that. 5 minus 3 is 2, so you get 2 squared plus 3 squared, which is the square root of 4 plus 9, or the square root of 13. For the other length, AB, point A is 0, 0, point B is 4, 6. So plug those into the distance formula. The square root of 4 minus 0 squared plus 6 minus 0 squared. It's the square root of 4 squared plus 6 squared, which is the square root of 16 plus 36. 16 plus 36 is 52. If you break 52 down, 52 is 4 times 13. 4 is 2 times 2. And so this is the square root of 2 times 2 times 13. I can take the square root of 2 times 2, because when you multiply the same number with itself, you get a perfect square. Square root of 4 is 2, so this is 2 square root 13. So notice AB is 2 times square root of 13, where DE is the square root of 13, and so AB is 2 times the length of DE, which mathematically showing that DE is half the length of AB. 23. Solve for x and then explain the theorem that allows you to solve for x. So first we need to know what we're looking at here. We have perpendicular bisectors. So I'll trace over them. Okay, the 3 blue segments are perpendicular to the sides of the triangle, and they bisect each side of the triangle, and they meet at what we call the circumcenter. The reason it's called the circumcenter is because that point is the same distance to all 3 vertices. And so the distance, let me label this, so A, B, C, and I'll call that point in the circumcenter D. So AD is equal to BD is equal to CD. Okay, that theorem is the concurrency of perpendicular bisector theorem is the name of that. It's a fancy name, but this is what it's saying. And that's why we call that the circumcenter, because we can think of that length to those vertices as a radius of a circle. And if if we made D the center and that the radius, we would be able to circumscribe that triangle, where that triangle, all 3 points of that triangle touch that circle. All this to say, AD and BD are equal. So we can say that 5x minus 8 is equal to 3x. Subtract 3x from both sides and get 2x minus 8 is equal to 0. Add 8 from both sides and divide by 2, getting x is 4. And that's the end of the review.